All right, welcome back. So just for anyone who's only joining us now, this is the second video in this two-part video. So it's a big long question, and the first one we answered part 1 to 4, and now we're going to do part 5 to 8. So if you're joining us now and you haven't seen part 1 to 4, would recommend trying to go back and find the previous video. But otherwise, yeah, let's just go ahead. So we all know the Bernoulli trials and how to use them. But now we're going to look at some difficult questions. So the first one we're going to look at is part 5. So the probability that the Irish family eat potatoes less than 9 times. All right. So we'll start down here. So less than 9 times. And this is sort of where it gets difficult. So less than 9 times. So what is less than 9 times? So in this case, what is n? What is or? And what are p and q? So n is still 10, but the number of successes or is kind of the hard bit. So p and q is still 0.7 and 0.3. So less than 9 times isn't one number, and that's the main problem. So less than 9 times is 0, 1, 2, 3, 4, 5, 6, 7, 8. All of these outcomes where they have potatoes 0 times, 1 times, 2 times, etc., they're all less than 9 times. So you have to find out the probability of each one and then add them all together. So I'll write that down. So prob of each and add all, I'll say. So that'll take ages. So it's 8 different calculations you have to do, and then you have to add all of those together to find your answer. So that takes a long time, and you can do it that way if you want, but there is a much quicker way. So I'll skip to yellow for that way. So one thing I haven't mentioned about Bernoulli's trials yet is if you find the probability of 0, 1, 2, 3, 4, 5, and so on, 6, 7, 8, 9, 10, and you add all of them together, so add, it'll be equal to 1. So each one of them will give you a decimal point, 0.3, 0.4, 0. Whatever. If you add each individual case together and add them all together, you will get 1 as your answer, as the total probability. And that's kind of the way it has to be, because each different case, they all have to add up to 1, that something will definitely happen. That's sort of what it means. So we can use that to help us figure out this question easier. So because all of these have to add up to 1, that means if we say 1 minus, we'll say prob of 9 and, no, not 9 and 10, 9 or 10, it'll be equal to the prob of 0, 1, 2, ... 7, 8, or the probability of less than 9. Okay, and so this is one specific case. We're looking at less than 9, but it's a really, really important case, and you need to remember this basically, because it can come up again and again. This part 6, probability they have potatoes at least 3 times, uses sort of the same method. So you need to remember that 1 minus the probability of something is equal to the probability of something else. So it's just it's a kind of a handy trick. You only have to calculate the probability of them having potatoes 9 and 10 times instead of doing for 0, 1, 2, 3, 4, 5, 6, 7, 8, which will just save you a lot of time. Okay, so I'll write it out all out on one line. So the probability of 10, 9, 0.7 to the power of 9 times 0.3 to the power of 1. I'm just going to put this in a square bracket, plus 10, 10, 0.7 to the power of 10 times 0.3 to the power of 0. So this is 1 minus, this is the probability of them having potatoes 9 times. So it's n is equal to 10, or is equal to 9. P is 0.7 to the power of 9, and Q is 0.3 to the power of 1. And this is the probability of them having potatoes 10 times. Stick all of that into your calculator, and we will find that the answer is 0.851. So that's the probability of them having potatoes less than 9 times. So hopefully that makes sense, that 1 minus probability of 9 or 10 is equal to the probability of them having less than 9. And that all comes from that if you add each probability up, it has to be equal to 1. So I'll skip on to the next part then, part 6. And we're going to use a similar method. So part 6 is the probability they have potatoes at least 3 times. So part 6, let me scroll down a little bit more. at least 3 times. So what does at least 3 times mean? The way of saying that is 3 or more, which means 3, 4, 5, 6, 7, 8, 9, or 10 times. So all of those different possibilities. So again, we could calculate all of those probabilities and add them all together, but there's 0, 1, and 2 are the ones that aren't included. So what we can do is we can say 1 minus the prob of 1 or, sorry, not 1, I should start with 0, of 0 or 1 or 2 will give us the probability of 3 or more. Okay, so that was a 1 minus prob of 0 or 1 or 2 is equal to prob of at least 3. Okay, so I'll just scribble that. I'll just go green. It's going to be 1 minus and then big square brackets. It's going to be 10, choose 0, 0.7 to the power of 0, and then 0.3 to the power of 1, plus 10, choose 1, 0.7 to the power of 1, and 0.3 to the power of 9. Sorry, that should be to the power of 10 here, my mistake. Plus 10, choose 2. In this case it's 0.7 to the power of 2 times 0.3 to the power of 8. So 1 minus all of that added together. Stick that into your calculator and you'll find that the answer is 0.998 times. So the probability they have potatoes at least 3 times is pretty high. Okay, and hopefully again that makes sense. It's the same principle, and it's something you definitely have to learn. So you have to make sure you understand this type of question and be able to answer other questions like it. Okay, so the next question, I'll scroll up to have a look. The probability they have potatoes for the first time on the 4th day. So it's this one here. The first time on the 4th day. So the last 2 questions are pretty similar. So we'll try and answer them together. I think I'll scroll across to answer them. So we're doing part 7. Let me just draw a line down here. Part 7. So it says for the first time, 4th day. Okay, so the probability that they have potatoes for the first time on the 4th day. So what that means is they have no potatoes, then they have no potatoes, and then they have no potatoes. So that's day 1, 2, 3, and then we'll say yes. So, and then on the 4th day they do have potatoes. On the 4th day they do have potatoes. So no, 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 and then yes. So we can answer this using Bernoulli's. So I'm going to break it up into 2 separate things. So the first one is just going to be the first 3 days. So we're going to say that n is equal to 3, or is equal to 0. There are no successes. P is still 0.7, so the probability of getting a potato, and 0.3 is the probability of failure. So it's going to be 3, choose 0, times 0.7 to the power of 0, times 0.3 to the power of 3, and, which we know in probability means multiplied, 0.7. So if you want, you could make a second Bernoulli for this, but it'll end up just being 0.7. So the probability you have potatoes on the 4th day is just 0.7. Okay, so if you multiply this Bernoulli's trial by 0.7, we will get, our answer will be 0.089. Okay, so that's how to do a question like this. It's splitting it up into two separate trials almost. So I'll scroll down, I'll do the last part, which is pretty similar. Go purple. So part 8 is very, very similar. So in this one, it's that the probability they have potatoes for the 3rd time on the 8th day. Okay, so that means in day, we'll say 1 to 7, they have two potatoes, or they have potatoes on 2 of the days, and then on the 8th day they have potatoes again. Okay, so you split it up into 2 separate time periods, so before the day and then on that 8th day. So in this one here, we have n is equal to 7, we have or is equal to 2, so they have successes of 2 days, or they have potatoes 2 days. P is 0.7 and Q is 0.3. So if we stick that into our Bernoulli's equation, it's 7 choose 2, 0.7 to the power of 2, and then 0.3 to the power of 5 times, or and, that they have potatoes on the 8th day. So that's just, again, is just times 0.7. So if we want to stick all of that into our calculator, we will find the probability is 0.018. Okay, so now that was a long video, so sorry about that. I'll just go back to the start and do a quick recap. So the Bernoulli trials, so it's a Bernoulli trials question. I've kind of incorporated almost every question they could ask you, every question I could think of anyway. So the first 4 are basic enough. They're just, that's what we covered in the last video. And it's just how to use Bernoulli's trials formula and how to do different numbers of it. And then part 5, 6, 7, 8 are more difficult. So the first 2, so part 5 and 6, are quite similar. The probabilities, they have potatoes less than 9 times or at least 3 times. And it's just, you can calculate each one of them individually, but it takes a long time. And I just showed you the little trick to avoid that. So 1 minus the probability. And then the other 2, so question 7 and question 8, there's another little trick. If it says something like the first time on the 4th day or the 3rd time on the 8th day, is you split it up into 2 separate time periods and you multiply the 2 different Bernoulli's trials. Okay, so hopefully that all makes sense. Sorry again for the long video. We'll see you in the next video, where we're going to start looking at arranging, choosing, and the box method. And that's going to be our last big topic in probability. Okay, we'll see you next time. If you enjoyed it, like and subscribe, and yeah, we'll see you next time.